Factoring special cases. There are special cases of factoring that involve perfect squares. So the first thing we're going to do is recall what our perfect squares are. So our perfect squares are things that multiply by themselves and give you certain numbers. So 1 squared is 1. So 1 is a perfect square. 2 squared is 4. So 4 is a perfect square. 3 squared is 9. 4 squared, 16, 5 squared is 25, and you kind of see where I'm going with this. So these over here are our perfect squares. And obviously we could go on. You might want to continue your list on a little bit farther than that. Now we're going to talk about factoring some perfect square trinomials. Okay, so first thing we want to do is figure out what they are when we actually multiply them. So if we were to multiply this out, we would have a squared plus ab plus ab plus b squared. So that means a squared plus 2ab plus b squared is going to be equal to a plus b, a plus b. So that would be how we would factor out this perfect square trinomial. And the next one, we have a minus b times a minus b, giving me a squared minus ab minus ab, double negative minus a negative plus b squared. So if I would to simplify this, I would have a squared minus 2ab plus b squared equals a minus b, a minus b. And that would be how you would factor out that perfect square trinomial. So let's do some examples of factoring out perfect square trinomials. The first example, we have x squared minus 12x plus 36. So the first thing I'm going to do is regroup. I have an x squared, and then I want it to be minus 2ab, so minus 2 times ab, which I need to figure out what that is, plus 36. Well, my perfect squares are going to be on the ends. So x squared is just going to be x squared. And then 6 squared is 36. So to get my inside term, I have to factor out a 2. So I have 2 times x times 6. And that should give me a negative 12x. 2 times 6 is 12. So yes, it does. So my final factored form would be we have an x and we have a 6. So we're going to have x minus 6, x minus 6. You might also write that as x minus 6 squared. Final answer. For this next example, again, we're going to split it up so that we know what we're looking at. We have x squared plus 2ab. We need to figure out what a and b are, plus 9. Okay, so that's going to give me x squared plus 2 times my a, which I know is x, times, I need to figure out what my b is. So I'm going to find my perfect square in the 9, so that would be 3 squared. So that makes my b 3. So if I take 2 times 3, I get 6, so that makes sense. So when I factor it out, I have x plus 3, x plus 3, which should also be written as x plus 3 quantity squared. Final answer. And this last example might be a little bit trickier, but we start the same way. First, we note that there are perfect squares on my ends. Okay, so once you note that, then we can say, okay, what is the perfect square of this? So we would be looking at 4, square root of 4 is 2x squared. Because then if I put that square in, then it would be 4x squared. And then 9 is equal to 3 squared. So those are my ends that I'm going to change. So I have 2x squared minus 2 times 2x times 3. And if you multiply that together, you would get negative 12x plus 3 squared. So that gives me my perfect squares, my trinomial factored out. So I have 2x minus 3 and 2x minus 3, because you take whatever's in here and whatever's in here. And then just write it twice. So my final answer is 2x minus 3 quantity squared. The other type of special case we have is factoring a difference of two squares. Okay, so if I were to take two binomials and multiply these together, a plus b, a minus b, then I would have a squared minus ab plus ab minus b squared. So if I were to simplify those, my ab's would cancel out because it's plus ab minus ab. So I'd be left with a squared minus b squared. So that means if I were to try to factor out a difference of two squares, such as a squared minus b squared, then I would just have two factors, and I would have a plus my second factor and a minus my second factor b. So that is how you would factor out a difference of two squares. So now we're going to do some examples of factoring out the difference of two squares. So the first thing we're going to note on x squared minus 64 is it is a difference. It is a binomial with subtraction. So it is a difference, and so we could be looking at a difference of two squares. So then I look at my two terms. They are both perfect squares, because x squared is just x squared, and 64 is 8 squared. So if I were to factor that out, I have my a plus my b, so I would have x plus 8, and I would have my a minus my b, x minus 8. So that would be how you would factor out the difference of two squares there. In this next example, we have 25x squared minus 36. So again, it is a binomial, two terms, and there is a minus sign. So it could be a difference of two squares. So now I have to look at my terms to verify that. Well, I know 36 is equal to 6 squared. So now I have to look at this other part. It's got two parts to it, but I know that the square root of 25 is 5, and square root of x squared is x. So if I have 5x squared, I get 25x squared. So there are two perfect squares in there. So when I'm writing it out, a plus b, a minus b, and I just fill in what I know. I know that it's 5x and 5x, and then plus 6 minus 6, and that would be your final answer. And the last example here, we have 16x squared minus 81. So again, there are two terms. And in between them is a minus sign. So it could be a difference of two squares. So now I'm going to look at the two terms. I know that 81 is equal to 9 squared. So that's the easy one. And then I have to look at the next part with the x. So I know that I'm going to have an x in there. And if I look at the square root of 16, that would be 4. So 4x squared, x, quantity squared, is 16x squared. So now I can factor it out. My a plus my b, my a minus my b, putting in 4x and 9. And that would be your factored form. So those are your notes over factoring special cases. Go through some practice problems. Make sure you're comfortable with these perfect squares and different types, if there's leading coefficients or not. And then you should be prepared for your quiz over this material.